So this is the first question I have taken. All are get previous year question and one question I have done by myself. So in this question, a two bus system is given, bus 1 and bus 2, and they are asking that what will be the reactive power, like what will be the rating of this QG2. Okay, so we can see that at this bus, the real power demand is 1 per unit. Okay, so in this kind of question, we can calculate the apparent power at this bus. Okay, why at this bus? Because if I know like reactive power demand at here, then we can calculate the reactive power supplied by this compensator. So see here, since this 1 per unit is supplied here, 1 second, 1 per unit real power is supplied here means this line is supplying a real power of 1 per unit. So in that case, we can say that the angle of this bus will be negative. So let's say 1 angle minus delta. Why minus delta? Because power will always flow like this. Okay, higher angle to lower angle. So this higher angle is 0 means here the angle will be minus delta. So we can write the current equation. What will the current? Current will be 1 angle 0 minus 1 angle minus delta divided by J
Sir,
0.5.
your screen is not visible.
Sir, visible, sir. Your screen visible, sir. No problem. Visible.
Not visible.
Visible, visible, sir. Visible.
Okay, okay. My network maybe.
Visible, sir. Carry on. Go ahead, sir.
Okay, once again I will explain. So here a two bus system is given. Okay, now it is visible. Because I think you can
Sir,
connect and disconnect.
visible.
Okay,
Visible, sir. Visible.
okay. So here a two bus system is given. So here bus 1 voltage is 1 angle 0 and bus 2 magnitude is 1 per unit. So since here 1 per unit demand is required, so this power will come from this one because this one will supply only reactive power. So this line, how much power it will drop from here to here? 1 per unit. So power is flowing from this to this direction. So we can say that the voltage will be 1 angle minus delta. So current we can write like this 1 angle 0 minus 1 angle minus delta divided by J 0.5. Okay. So what will be the apparent power here? Apparent power will be S is equal to VI conjugate. So that will be V will be 1 angle minus delta and I conjugate will be 1 angle 0 minus 1 angle minus delta divided by J 0.5 conjugate of this one. So it will be this angle above it will go minus and minus conjugate will be plus. So we can write that 2 angle 90 minus delta minus 2 angle. So this will be minus delta minus 90. So 90 plus delta, 90 plus delta minus delta, it will be 90. So this will be the equation of the apparent power. S will be 2 angle 90 minus delta minus 2 angle minus 90. So we'll do the cosine. So P will be cosine of this. So P will be 2 sine delta and Q will be 2 cos delta minus 2. Is it clear to all these equations?
Sir,
Like,
can you repeat S equal to VA conjugate from that point?
okay. So if we are doing like this, no need to remember any formula. In that case, chances of mistake will be less. Okay, if we are remembering formula, sometimes we will do plus minus mistake. But if we are going by basics, chances of mistake will be negligible. So first I am doing current. Current will be I will be this bus voltage 1 angle 0. Okay. So the bus 1 voltage is 1 angle 0. Bus 2 voltage I am assuming 1 angle minus delta. Why minus delta? Because power is flowing from this to this direction. Okay, 1 per unit of real power is flowing from this to this direction. So obviously this angle will be negative. So I am calculating 1 angle 0 minus 1 angle minus delta divided by this reactance J 0.5. VI conjugate I am calculating here at bus 2. Here I am calculating the S apparent power. So what is the voltage here? 1 angle minus delta. 1 angle minus delta multiplied by this current. Current is 1 angle 0 minus 1 angle minus delta divided by j 0.5. So see here, this will have a magnitude of 0.5 and angle of 90 degree. J means 90 degree. So if it will go at top, that will be minus 90. Okay. So minus 90 conjugate will be plus 90. So plus 90 into 1 angle minus delta. This will be 2 angle 90 minus delta. First term. This one. Minus this second term will be there. So second term will here 90 degree angle contribution will be there. At top it will go minus 90. Here minus delta already there. So minus 90 minus delta. If we will take conjugate of minus 90 minus delta, that will be 90 plus delta multiplied by minus delta. So 90 plus delta minus delta, it will be 90. So second term will be 90. Is it clear now?
Yes, clear,
Oh,
sir.
okay.
Thank you. Thank you.
Okay.
Sir,
Yes, you can ask again. Hello.
Nothing, sir. Go ahead, sir.
Okay. So for real power, what we are doing, we are taking cosine of apparent power. So cosine, if I'll take cos 90 minus del, it will be sine del. So real power will be 2 sine del. And reactive power, what we are doing, we are taking sine. So cos 90 will be 0. First term will be 2 sine del only. Second term will be sine 90 minus del. So 2 cos del minus sine 91. So 2 cos del minus 2. So Q will be 2 cos del minus 2 and P will be 2 sine del. Okay. So here what is the P flowing from 1 to 2? Since here demand is 1, so this real power will come from this one. Because this is a reactive power compensator, it will not supply a real power. So all real power will come from this one. This generator will supply. So we can say that 1 is equal to 2 sine del. So what will be the delta value? Delta will be sine inverse 1 by 2. So it will be 30 degree. Okay. What will be the reactive power? From this equation we can calculate. So 2 cos 30 minus 2. How much? Can anyone calculate this value? 2 cos 30 minus cos 30 root 3 by 2. So root 3 minus 2.
Minus 0.267.
Oh, okay. Minus 0.267. Okay. So this reactive power will flow here. If you see here, this is the reactive power. So this value is Q is minus 0.267. So we can say that this power is flowing in reverse direction at this node. 0.267 reactive power is here. Since in this direction it is coming as negative, so we can say that this power is flowing in this direction 0.267. Okay. So how much this should contribute? This should come from some source. So here a compensator is given. So this will supply that required reactive power to maintain this V2 at 1 per unit. V2 will be 1 per unit when this source will supply this 0.267 reactive power. So answer will be this D. Is it clear?
Clear.
Okay. So again some other calculation we will do in same question. So I'm going to calculate real and reactive power here at bus 1. Okay. So at bus 1, what is the voltage? 1 angle 0. Okay. And current will be same. Here also current will be same. So current will be 1 angle 0 minus 1 angle minus delta divided by J 0.5. So at bus 1, S1 will be 1 angle 0 into here 1 angle 0 minus 1 angle minus delta 1 angle 0 minus 1 angle minus delta divided by J 0.5. So this will be the conjugate. So here it will be J 0.5 at top it will be 2. So 2 angle, here it will be minus 90 conjugate it will be plus 90 minus 2 and here it will be minus 90 minus delta. So conjugate will be 90 plus delta. So this will be the apparent power equation at sending end. What will be the real power? If we'll take cosine, so cos 90 plus theta minus sine theta, so it will be P will be 2 sine delta. It will be same. If we'll calculate at both the ends, P will be same. What will be the Q? Q will take sine, so sine 91, so Q will be 2 minus and sine 90 plus del cos del 2 minus 2 cos del. So at the receiving end here, this will be the reactive power equation 2 minus 2 cos del. Here it was 2 cos del minus 2. Here it will be 2 minus 2 cos del. So what will the reactive power here? Delta will be 30 degree. So 2 minus 2 cos 30. How much? 2 minus root 3. So it will be 0.2668.
0.2679.
Okay. So from this side also, so we can say that this line requires reactive power from this side and this side both. From this side also 0.268 and from this side also 0.268. So who is consuming this reactive power? This reactive power is consumed by this line reactance. Okay. So we can verify this. How we can verify? We can calculate the current through this line, and I square x will be reactive power consumed by this line. Okay. So we can calculate the current. What will be the current value? Since delta is 30 degrees, so I will be 1 angle 0 minus 1 angle minus 30 divided by J 0.5. So see, if we are dividing any two phasors, okay. So if we are dividing two phasors, so magnitude will be magnitude of numerator divided by magnitude of denominator. Okay. So we can do like this. One, like in reverse way also we can do. See both sides. So minus like 1 cos 30 and it will be minus j sin 30 divided by j 0.5. So if we'll calculate magnitude of this part and we'll divide by 0.5, so we can find the magnitude of the current. So cos 30 will be root 3 by 2. So 1 minus root 3 by 2 plus j 0.5. So can anyone calculate the magnitude of this one? 1 minus root 3 by 2 plus j 0.5. So it will be this square plus this square under root. Okay. Can anyone calculate? I'm also calculating. So 1 minus root 3 by 2.
Zero
How much?
0.5176 at an angle.
Oh, angle is not required, only magnitude. So this square plus this square, how much? This square plus
0.517.
2 minus root 3. It is coming as 2 minus root 3. A square plus b square. Okay. And under root, if we'll do, it will give magnitude of this one. Okay. And divide by 0.5. So it will be the magnitude of the total current. Okay. This will be the magnitude of the total current. So this square into 0.5. This square into 0.5, that will be 2 minus root 3 divided by 0.5. So this will be the total reactive power. I square into XL. This is I. So that should come. Yes, you can ask.
0.535, sir, answer.
This should be twice of this one. Twice of 0.268. Everyone is getting?
0.536.
That will come like 2 adjust 6 to 6 to 5. 0.526, I think.
536.
Okay, 5. This will come twice of this one. Okay. So I square x also if we are doing, then we are getting I square x is equal to reactive power 0.536. So here from this side 0.268 it is supplying. Here also 0.268 is supplying. That is consumed by this line. And if we'll do I square x, then the summation of this both reactive power will be the I square x. Now is it clear to all? So no need to memorize the formula. I will suggest you, like, you just whatever the value will be given, you just apply this one line equation VI conjugate. Okay. Directly we apply in value form only. In form of value only we should apply. And then after that you can sine and cosine you can take. You can solve the question. Is it clear? Should I move to the next question? Can anyone reply?
Yes, sir. Yes, sir.
Okay. Okay. So this is the next question in 2014 gate. So here this is the extra thing is given in the question. No need to take care about this. So bus 2 angle is given is 1 angle delta 2 and bus 1 is V1 angle 0. Okay. So here what should be the value of delta 2? It should be negative or positive. Can anyone tell? Delta 2 should be positive or negative?
So negative.
Yes, because since power is flowing from here to here, so always power flow from a higher angle to lower angle. So delta 2 should be negative here. Okay. So we can write the SI conjugate here, SVI conjugate equation here. So S will be VI conjugate. What is the V value? V is 1 angle
1 at an angle delta
delta
2
2. And I will be V1 angle 0
minus
minus 1.
1 at an angle minus delta 2.
No, not minus. Whatever is given, that only we will keep here. Okay.
Okay, okay.
1 angle
By
delta 2 divided by J 0.1.
J 0.1.
So take the conjugate of this one. So we can write this, if it will go at top, it will be 10. Okay. So 10 V1 angle, this will be minus 90 at top, so plus 90. So 90 plus delta 2 minus 10, and it will be minus, like it will go at top, it will be minus 90. So delta 2 minus 90, 90 minus delta 2. So it will be 90 minus delta 2, and if this will be go inside, it will plus delta 2, so it will be 0. So equation will be 10 V1 angle 90 plus delta 2 minus 10 angle 90.
90.
Is it clear? This apparent power equation. Is it clear to all?
Clear, sir. Clear.
Okay. So now we can take like sine and cosine. So real power will be, so we can take sine. So 90 plus theta cos. So P will be 10 V1 cos delta 2. What will the value of Q?
Sir,
See,
sir, I have, sir, 1 minute, sir.
you can
Sir,
ask.
sir, what is the formula for real power, sir?
See, real power means S we are taking
Hmm.
sine. So no. I have done mistake here. Is like last all questions I have taken. If you will take
Sir,
cosine, then it will come as sine. Okay. We have to take the cosine of the actual equation. So if we will take cosine of this one, so cos 90 plus theta, it will
okay,
come
sir.
as minus cos 90 plus delta 2. See, all sine tan cos we formula we know. This is all sine tan cos. So it is coming here. Okay. So cos 90 plus theta, here it will be minus 90. So minus 10 V1 sine delta 2. And Q will be like in terms of Q, will take sine. So 10 V1 cos delta 2 minus 10. Now is it clear to all?
Yes, sir.
So this will be the two equations.
Sir, in this, what is V?
V1,
Sir, here 90 plus theta to one angle only considered, sir.
you can ask again.
Here for active power only 90 plus theta to considered, sir, angle.
Uh,
Ang-
See, whatever will be apparent power equation, okay, for that angle will take cosine. So 10 V1 cos 90 plus delta 2 minus 10 cos 90. So cos 90 will be 0. Okay, second part will be 0. So for
Okay.
real power, we will take cosine of this whole equation.
Okay.
For reactive power, we will take sine of this whole equation. So sine 90 plus delta 2. So all sine will be positive in the second quadrant. So
Okay.
sine 90 plus delta 2 cos delta 2, and this sine 91. So it will be minus 10. Okay.
Okay. Got it, sir.
Sir,
Thank you, sir.
Yes, you can ask.
Sir, in S is equal to VI, sir, V is receiving end voltage or standing end voltage?
Now see here, I am applying this formula at this node here. I am applying this formula at here at this node. So here the voltage is 1 angle delta 2. Okay, at this node, I'm applying this equation. Is it clear? Same thing I will do here also.
Okay.
I will do for this node also. Like last question I have explained. One time I have done here, another time I have done here. Then we have observed that whatever the reactive power is supplied by this one, and from negative from this one, that will
सर
be. Yes.
हेलो
Yes, you can
सर
ask.
इस केस में ये तो जनरेटर साइड जो है सर,
Yes.
जनरेटर साइड तो सर ये जैसे रिएक्टिव पावर को इक्वेट कर दिए 1 से, और
Yes.
उसके बाद एक्टिव पावर को इक्वेट कर दिए क्योंकि सर जनरेटर ही सप्लाई करेगा और सब कुछ। तो
Yes.
ये एक्टिव पावर को सर ये इक्वेट कर दिए ये आपको एक्टिव पावर के फॉर्मूला से, और रिएक्टिव पावर को सर ये इक्वेट नहीं कर सकते 0.5 से
At this side. No,
No,
here,
yes, sir.
here we cannot equate, because here, if we are calculating that will be like summation of this one also.
Yes,
Like the reactive power supplied from this one, that will be a combination. Like that will not be a this one.
Okay, means generator is giving to the shunt and the bus 2 also.
Yes.
Reactive power, right?
Yes. See,
Oh,
here why I'm considering this one, because this load is given here.
it's always confusing.
Okay. So here, why I'm doing at this node, because this load is given at here. This node we can write the power flow equation, like power balance, how much input is coming, output is going. But see here, since only reactive element is there at middle point, we can say that whatever will be the real power at this node will come at this node. But in case of reactive power at this node and this node will be different. Why different? Because at middle reactive element is there. If R plus Jx will be there, see,
okay.
if R plus Jx will be there, in that case we cannot say that this real power and this real power will be same, because some real power will be consumed by the resistance also. You are getting? See.
Yes, means if the shunt have something register, means something register part, then it won't be possible.
Then the here real power and here real power will be different. Since this is a reactive element, so this is also consuming some power, I square into x. This is also consuming some power. Okay. So some power is consumed by this load, some power is consumed by this reactive element. So total will be supplied by from this side. Okay. We will do in this question only. I will calculate reactive power at here also. Then we will do the balance. Okay. I will do the power balance here. Then it will be more clear. Okay. So what is the P value is given? P value is 1. So we can say that minus 10 V1 sin delta 2 is equal to how much? 1. And Q will be 0.5. So 0.5 equal to 10 V1 cos delta 2 minus 10. Okay. So we can say that sin delta 2 will be minus 0.1. So sin delta 2 is equal to minus 0.1. 1 second. V1 sin delta 2. So V1 sin delta 2 is equal to minus 0.1. And from this equation we can say that this will be 10 plus 0.5, so 10.5. So we can say that V1 cos delta 2 is equal to 1.05. Is it clear? These two equations. From this one, V1 sin delta 2 is equal to minus 0.1. From this one, V1 cos delta 2 is equal to 10 plus 0.5 divided by 10. So that will be 1.05. So from these two we can divide. So tan delta 2, we can say that minus 0.1 divided by 1.05. So inverse of this will be angle delta 2. Delta 2 will be tan inverse minus 0.1 divided by 1.05. Can anyone calculate this value? Tan inverse minus 0.5.
Minus 5.44 degree. Minus 5.44 degree.
Yes, correct. Minus 5.44. So we have calculated the delta 2. So delta 2 already I have said that it should be negative only. But but we have considered it positive, so it is coming as negative. So delta 2 value will be minus 5.44. This is in the option 1 only. So if in exam we are calculating, like optional question will be there, no need to calculate all the things. One value is matching means directly we can take the question. No need to calculate V again. Okay. So V also we can calculate. So V1 sine minus 5.44. This should be equal to minus 0.1. So V1 value we can calculate from here.
सर अगर न्यूमेरिक इंटीजर टाइप होगा तो उसमें माइनस लिखेंगे किसी 5.44
See, if it will be a
because delta
numerical value, so delta 2 we are calculating, delta 2 will be minus 5.44.
we have to write minus
Yes,
5.4.
minus 5.4 because we have assumed the variable delta 2. If it will be minus delta 2 written here, if it will be written as
So
minus delta 2,
5.4.
so what will be the value of delta 2? So delta 2 will be 5.44. That we should take
Okay,
care.
okay,
What is given?
okay, sir. Okay, sir.
Okay. So here it will be divided by sine minus 5.44. How much it will be? Minus 0.1 divided by sine minus 5.44. How much? 1.0.
1.0548.
Yeah,
1.0548.
yes, correct. So 1.0548. Okay. So this will be the answer. 1.0548. So this will be the answer. So in exam, directly option without solving also option we can eliminate. Okay. See, we can. This will be the. This will not be the final answer since angle is positive. This will discard. This will be discarded. After that, V1 in like this 1 per unit should be equal to V1 into V2 into like sine delta. That will sine only will come. Okay. So we can verify from options. Like no need to solve directly 1.05 into 1 into sine minus 5.44 if we'll do, we'll get the answer. This will not give the 1 per unit answer. Okay. So without solving also from option also we can solve this question. Like let's say we'll verify this voltage is 1.1. So 1.1 into 1 into sine 6. It will not be 1 per unit. Here also if we'll do 1.1 into 1 into sine 27.12. This will also not give 1 per unit. So this option only will be the valid option. Is it clear? Like without solving also we can do by this method. Like option we can discard. Is it clear to all? Should I move to the next question? Can anyone reply?
Sir, yes, sir. Yes, sir.
Okay, okay. So
Sir,
for
1 minute,
this
sir.
this question,
If you
what
don't,
okay, you can ask.
if you don't mind, sir, P equal minus 10 V1 sin delta 2, I understood, sir. But Q equal to 10 V1 cos delta 2 also understood, sir. But why minus 10, sir, here?
See, this is the equation. This is the equation. This
Yes, sir.
equation is clear. 10
Okay,
V1.
clear, sir. After here,
So
clear, sir.
10. So it is minus 10 90. Okay,
Yes, sir.
angle 90. So if
Yes,
we are taking cosine of this one, so cos 90 will be 0. Second term will be 0. But if
cos
we are
90,
taking cos 90 is equal to 0. So
0.
second term is not here. But if we are taking sine, why we are taking sine for reactive power? So
Reactive
10
part.
V1 sine 90 plus delta cos delta 2 and
Yes,
minus
sir, I got it.
10 sine 90. So sine 90 will be 1. Okay. So what will be the step? First you do the VI conjugate. Okay. After some expression will come. So that expression we will take cosine for the real power and sine for the reactive power. Now is it clear?
Clear, sir. Clear, sir.
Okay. So now second part, what I'm going to do, I will calculate the all the real and reactive power here at sending end side. Okay. So here we can write the equation. What will be the difference? Difference will be the voltage here will be V1 angle 0. Okay. Here the voltage was 1 angle delta 2. Here the voltage will be V1 angle 0. So we can write the equation V1 angle 0 into V1 angle 0 minus what was the here 1 angle delta 2 1 angle delta 2 divided by J 0.1.
J
Is correct? Okay, J 0.1. So this we will take the conjugate. Okay. So this is the apparent power. What will the value? Value will be V1 square. Okay. Divided by 10 V1 square. Here it will be 10 V1 square. 10 V1 square at an angle. How much? This will go at top.
at an
So
angle minus 90.
so minus 90 will be plus 90. Conjugate if we will take, that will be plus 90. Okay. Here at top it will go minus 90. Minus 90 conjugate will be plus 90. In second case, minus 10 V1 angle. This delta 2 minus 90. So 90 minus delta 2. This will be the equation. Is it clear?
Clear, sir. Clear.
Okay. Now real power and reactive power. So real power, what we will take? We will take cosine. Okay. So one second. One second. So here, here the angle is coming as negative. So real power, if we'll take cos 90 minus delta. One second. Delta 2 was negative or positive? It is showing as positive. Positive, but we are getting delta 2 negative. Okay. So correct only. So what will be the real power? We'll take the cosine. So cos 90, this part will be 0.
Zero, sir.
So
Zero, sir.
P will be minus 10 V1
Cos
sin
of okay. Sine
cos
delta.
90 minus delta sin delta. So same we are
Sine
getting, P value we are getting same. Here also we got the same, minus 10 V1 sin delta 2. Here also we got the same value, P. What will be the Q? Q will be 10 V1 square.
10 V1 space sine 90.
No, here, okay, sin 90 will be 1. Sin
Yes.
90 will be 1. Minus 10 V1 sin 90 minus delta. How much? Cos delta. Cos delta. So this will be the reactive power equation at the this end. This end is still be the reactive power equation. Okay. Is it clear?
Clear, clear, clear.
So we can calculate this power, reactive power. How much? V1 already we got. How much it will be? 10 into 1.0548. 1 second. 1.0548 whole square minus 10 into 1.0548 into cos 5 point, how much? Minus 5.44. So 5.44. What will be this value? Can I remember? 10 into 1.0548 whole square minus 1.0548 into cos 5.44. 0.6255 it is coming. 0.6255.
Yes, sir. 0.625. right, sir.
Okay. So this will be the
0.625.
okay. So this will be the reactive power 0.6255. Okay. So at load side, what is the reactive power? 0.1, 0.5. So what will the reactive power consumed by this line? So reactive power consumed by this line will be 0.6255 minus 0.5. So that will be 0.1255. So this much reactive power is consumed by this line. Load is taking how much? 0.5. But source is supplying how much? 0.6255. So this extra 0.1255, this is taken by this reactive element. Okay. So now we can verify by calculating the current value also. Like current will calculate and then will I square into X will do. That should come this value 0.1255.
Hello.
Yes, you can ask. Am I audible?
Sir, sending,
Yes.
yes, sir.
You can ask.
Sir, sending and reactive power is 0.6255 and receiving and reactive power is 0.5.
No, no.
So,
This is taken by the load. Okay.
okay, okay, load, okay,
This reactive power is taken by the load, not here.
okay. But sir, from the sending end, we have one element also connected in that J2
J2, sir.
that will
What about
also
J2, sir? What about
Which one?
J2?
Which one? Which one?
J2.
See, so here, so after this bus we are looking. Okay, J2 also it will draw some power, but no need to take care about this because this is isolated from our main circuit. Okay, here also J2 will draw a reactive power that will be V1 square by 2. That will be a different thing. That is not included in the question. After, if we are want to calculate reactive power here by source, so source will supply the reactive power. So this reactive power plus this reactive power total. Total will be supplied by, if in question they will ask like what will be the reactive power supplied by the source. Okay, G1. If question will be like this, reactive power supplied by the source G1. So G1 terminal is this one. After the terminal, how much reactive power we are getting? 0.6255. So answer will be, for that question, answer will be 0.6255 plus this V1 square. So V1 how much? 1.05 something. 1.0548. Okay. So 1.0548 whole square by 2. So this will be the answer. If question will be framed like this, what will be the reactive power supplied by the G1? So G1 will supply this reactive power and reactive power demand here. Is it clear?
okay.
Hmm. So
And
here,
0.6255 means reactive power supplied by the source, sir. G1,
not source, zero. Here we are, this bus I am writing the equation in this direction. Okay.
for bus 1. Okay.
So bus 1 at output direction I am writing the equation. What is the current
Okay.
here? Current I have written and voltage V1 angle 0 I have written. So that will give the reactive power supplied by this node in this direction. Okay. But if it question will be asked what will be the source reactive power, so source will be this plus this. That will be the answer. Okay.
Okay.
So how much
Got,
we got?
got it, sir.
0.6255. So 0.6255 is supplied by this side. This side 0.6255. And here,
Sir,
yes, you can ask.
sir, as you said that the power flow from higher angle to lower angle, if suppose we have capacitive load, then power cannot flow.
Capacitive load, only reactive power you are telling.
No, no, I think you said no,
See, power will flow
that
from higher angle
power.
to lower angle always. Okay.
Yes,
If
sir. Yes, sir.
you can take anything, any example you can take. You make two angles, and you calculate the VI conjugate. If you can see that the power will, the magnitude of power will be positive from higher angle to the lower angle. Okay. After calculation also you can see that that will be from higher angle to lower angle. So here this is higher angle 0. So this angle will be negative. Negative means the lower angle. Then power will flow from this direction to this direction. Is it clear?
Okay. Sir, let's suppose we have leading load, then power cannot flow to the load.
See, load, in terms of load you are telling. This is, I am telling in terms of bus. Okay, bus will have some voltage. Bus means what?
Okay.
Bus means we are telling that this bus have, this is not a load. Bus means power system, some bus will be there. At that bus, we are maintaining some voltage and some angle. Okay. So this will be power flow equation between two buses, not between source and load. Okay. Load will be, whatever load will be there, that will draw power. Either it will be a leading load or lagging load, that will draw power, real power. Is it clear?
Clear, sir. Clear.
Okay. Okay, so how much we got the value? 0.62, 0.6255. So 0.6255 is the reactive power supplied here. This bus will supply 0.6255. Okay, and here what is the reactive power? That will be drawn by the load. Here it will be 0.5. So 0.1255 extra will be consumed by this line. So now we can verify this. Just we will calculate the I value and then I square into 0.1 will do. Okay. So I, how we can calculate? I will be, what is the V1? 1.0548 minus 1 angle minus 5.44 divided by J 0.1. Okay. So this is the value of the I. Can anyone calculate the magnitude of this current? They have calculated. Just to verify, I am doing this. Like that part should come as the reactive power consumed by the line. Okay. So 1.0548. So 1.0548 minus 1 angle minus 5.44 divided by 0.1 J. So 1.118 magnitude I am getting 1.118. Everyone is getting this magnitude 1.1182. I magnitude will be 1.1182. So I square into X.
Yeah, 1.114.
You are getting 1.114. So almost same.
Yeah.
So we'll do
Okay.
I square into 0.1. Okay. 1.118 square into 0.1.
0.055.
0.1249 I am getting. 0.1249. This value I am getting 0.1249. Same we have calculated here. Almost 0.125. Is it clear?
Yes, sir.
So what is the observation? Observation is why the sending in and receiving in reactive power are not equal, because sending will end will supply some reactive power extra that will be consumed by the line reactance. Okay. And if resistive part will be there, if in this one R will be there, R plus Jx will be there, this line will be R plus Jx. In that case, sending in and receiving in real power also will be different, because this line will consume some real power, I square into R. Is it clear?
Yes, sir. But sir, in this case, there is no resistance.
That's why real power is equal. Real power equation I have written in two ways. One equation I have written at the sending in, and another equation I have written at the receiving in. So in both way, what we are getting, real power equation is same. P is equal to minus 10 V1 when I have written at the receiving in, and again I have written for sending in. So in that case also, what we got, P is equal to minus 10 sine delta 2. So we can conclude that if only reactive power will be there, a reactive element Jx will be there. So in that case, sending in and receiving in real power equation will be same. Clear?
Yes, sir.
Okay. Okay. So if no doubt will be there, I will move to the next question. Should I move?
Okay, sir. Okay.
Yes, sir.
Okay. So what will be my suggestion now also, like always go by VI conjugate. No need to remember formula E cos delta minus V or something, some formula we used to remember. That formula no need to remember. Just we should follow VI conjugate, this equation. Okay. And this we can calculate at different nodes. This equation we can calculate at different nodes. Okay. So this is 2018 question. So in this case also I'm going to calculate one S here. Apparent power I will calculate here, and one S I will calculate at here. So this is S1 sending in and S2 receiving in. Okay. So S2 I am going to calculate. So S2 will be V2 into I conjugate. So 1 angle 0. The voltage here 1 angle 0 into 1 angle delta minus 1 angle 0 divided by J 0.1 conjugate. So what will be this value? This is delta minus 90. So it will be 10 angle 90 minus delta minus 10, and this will be minus 90, so 10 angle 90. Is this equation is clear to all? Just one line equation. Vi conjugate means just one line
Clear,
equation.
clear, sir.
So P will be 10. So we'll take cosine. So 10 sine delta, and Q will be 10 cos delta minus 10. It clear? Just for case of real power, we will take cosine. For case of reactive power, we will take sine. So sine 90 will be 1, so it will be 10. Okay. Similarly, we can write equation for this point, sending end point. Okay, here. So what will be the equation here? Equation will be S1 will be 1 angle delta into 1 angle delta minus 1 angle 0 divided by J 0.1. This whole conjugate. So this will be like delta minus 90. So 90 minus delta plus delta. So it will be 10 angle 90 minus 10. So at top it will go minus 90 plus 90. So it will be 90 plus delta. Get clear this calculation? The first term will be delta minus 90. Delta minus 90 conjugate will be 90 minus delta. And 90 minus delta plus delta will be 90. And here it will be minus 90 and conjugate will be plus 90. So plus 90 plus delta, it will be 90 plus delta. Is it clear? So from here, what will the P value? P will be, will take cosine. Clear?
Minus 10 sine delta.
No. So cos 90 plus delta, it will be minus sine. See, here it will be, all will be positive sine. So cos 90 plus delta we are going means that will be minus sine delta.
Okay. Plus 10 sine delta.
So P will
Final
be
answer.
10
P
sine.
equal plus sine delta.
P will be 10 sine delta, and Q will be 10 minus 10 cos delta, because
Okay.
cos will sine will be positive here. Here all will be positive. Here sine will be positive. So sine 90 plus delta, but that will be plus cos delta. So Q will be 10 minus 10 cos delta. P will be 10 sine delta. So what is the observation here? At sending in and receiving in, real power is same, but reactive power is different. Okay. So now we can see from the diagram these two equations after written. So here this source is supplying 15 real power, 15 per unit, and this load is drawing 20. So how much real power will flow in this line? 5 per unit will flow from this here to here. Since this source is supplying 15, this load is
Got
drawing,
it, sir. Got it.
so 5.
Got it.
So 5.
Right.
So this both side equation is real power equation is 10 sine delta. So 5 should be equal to 10 sine delta. Is it correct? This 5 should either here or here. From here also real power will be 5. Here also real power will be 5. So 5 will
Delta
be
equals 30 degrees.
so delta will be 30
30
degrees.
degrees.
Okay. Now second case we can calculate reactive power here Q1. What will be the Q1 value? Q1. What will be the Q1? Q1 means this one. 10 minus 10 cos delta. So Q1 will be 10 minus 10 cos 30. How much? Cos 30 means root 3 by 2.
0.33, sir.
No. 10 minus 10 cos 30. How much? 10 minus 10 into cos 30.
10 minus. Sir, 1.339, sir.
So it will be 1.339. Similarly, we can calculate for this one Q2. So what will be the value of Q2? 10 cos 30 minus 10.
Minus 10. Sir,
So
minus 1. Minus
minus
1.339.
1.339.
9.
Okay. So from this side 1.339, from this side so here minus 1 means this side it will come 1.339. See, minus direction was for this direction. So we can say that this from bus to this direction, how much reactive power is flowing? Plus 1.339. Clear? What we have calculated was for this direction. So for this direction it is coming negative, means we can say that in this direction the reactive power flow is 1.339. So what will be the total reactive power consumed by this line? That will be 2 times of 1.339. Is it clear? P line will be from this side and this. So 2.68. Okay. So line will consume how much of reactive power? 2.6. One from this side and one another from this side. Okay. Coming to the QG1. Okay. So how much is the reactive power consumed by this line? 5.
J5.
So 5
J5.
plus this 1.34. 5 plus 1.34. So QG1 will be 6.34. This 5 plus this 1.34. Is it clear?
Got it.
And
Clear, sir.
QG2 will be this 1.34 and this 10. Here reactive power is 10. So 10 plus 1.34, QG2 will be 11.34.
11.34.
It will be clear, I think.
Clear, sir. Thank you, sir. Simple manner you explained, sir.
Yes. Don't need to remember any formula. Just this VI conjugate you should remember. Then you can solve. Again, we can verify like I square x if we'll do I square into x. Then we will get this 2.68. That will be the reactive power consumed by this line. Okay. So here we can verify that. So what will the I value? I will be 1 angle 30 minus 1 angle 0 divided by J 0.1. So what will be the magnitude for this current? This will be 1 cos 30 plus J
Sir,
sin
5
30.
amps.
This magnitude, how much you are getting? 5.
5.
Okay, let me calculate also. So 5 square into 0.1, how much you are getting? 5 square into 0.1. That should be 2.68. You are getting
2.5. 2.5.
almost
I
approx.
think 2.5.
Okay, approx we are getting. So 1 cos 30 plus j sin 30 minus 1. So cos 30 how much? Root 3 by 2 minus 1 plus
34.7.
this 0.5. Okay. So this square, this is the complex number at numerator, and denominator it will be j 0.1. So this magnitude, okay, divided by this magnitude, it will be the total magnitude. Okay. So magnitude will be root 3 by 2 minus 1. So 1 second. Root 3 by 2 minus 1 whole square plus 0.5 whole square. So this one I am getting 2 minus root 3. At top magnitude I am getting 2 minus root 3 under root, and below magnitude will be 0.1. So I square into x will be 2 minus root 3 divided by 0.01 into 0.1. How much? Can anyone calculate this value? 2 minus root 3 by 0.1. So 2.679 I am getting.
2.67. 2.67.
So same we are getting. So in some question, if line current information will be given, okay, maybe indirectly they have given line current information. So in case of line current information, no need to calculate this one. Some part like this also we can calculate. I square x directly we can do, and then we can use, we have to take care like what information is given, and in short way how we can use that information to get the final answer. Okay. So for this question also no need to solve this much. How we can approach for this question, like from options. So let's say I have calculated S1 only. Okay. At this side only I have calculated. So I have calculated this 1.339 here. This one I have calculated. So this side only equation I have written. So what will be the QG1? QG1 I have calculated 6.34. Okay. So 6.34 means already we know from this side what will be the, so this will be 1. Here it will be positive means this side it will be negative. That kind of things are coming in all our explanation. Okay. So 6.34, only two options are there. Okay. In second case, we can see that this QG will supply minimum 10 reactive power, QG2. But here also some part will be there. Here it will not be 0. Okay. Since these two voltage are 1 per unit, here it will not be 0. So this 10 option will not be correct. Since this only is required, 10 only required by this only, this QG2 should be greater than 10. So first value we got 6.34 and QG out of that one this 10 is there. So this will be discarded. So this will be the final answer. Is it clear?
Clear, sir.
Like no need to solve all the parts. Like smartly we can discard some answers. Okay, this 5 and 5 will not be correct because this will give more than 5. Directly without solving also we can say that with here this is 5. So minimum 5 this should supply more than 5. So 5 answer will be incorrect. So this 6.34 will be correct. Here also this should supply more than 10. So more than 10 it is supplying. So this will be the final answer. Like this we can discard the options. Like always no need to solve the question. Sometimes we can see the options and then we can discard the options. Is it clear? That will save our time. Like 3 hours exam is there, like in that if we are saving some time in some 1 or 2 or 3 questions, that will be helpful in solving the tough questions. Okay, is it clear?
Clear, sir.
Okay, okay. So I'm moving to the next question. This is the last question today. So this question, the simple question I have done by myself, and just some data I have taken. So here a one angle delta voltage source is given and the receiving in voltage is V at an angle 0. Okay. So in question it is asking that to maintain the V value at 1 per unit, this magnitude I have to maintain at 1 per unit. So to maintain this voltage at 1 per unit, here I have connected a compensator. Okay. So how much reactive power should be supplied by this compensator to maintain this reactive power voltage at 1 per unit? Okay.
0.5, sir. 0.5.
No, see, not correct. So I'm going to solve this. So here I'm going to write the equation, apparent power equations I'm going to write for this node. Okay. So what will the apparent power S will be? One angle B angle 0. So B is 1 to maintain 1. So 1 angle 0 into 1 angle delta minus 1 angle 0 divided by J 0.5 whole conjugate. So what will be this value? 0.5. So it will be 2. So 2 at an angle, this is delta minus 90. So 90 minus delta minus 2 at an angle. So minus 90 it will be plus 90. This will be the apparent power equation at receiving end side. So what will the P value? P will be 2 sine delta and Q will be 2 cos delta minus 2. Is it clear? These two equations. Is it clear to all?
Clear. Clear.
Okay. So from this equation we can calculate the delta value. So what will be the delta? P is 1. This compensator will only supply reactive power. So this P here is 1 means this side also P will be 1. So 1 will be 2 sine delta. Clear? So delta how much it will be?
30 degrees.
Delta will be 30 degree. Okay. So delta will be 30 degree. So what will the Q value? Q will be 2 cos
Minus 2. Minus 0.267 Q value.
minus 0.267.
7.
Okay. So see here the Q flowing in this direction. Q flowing in this direction how much? Minus 0.267. So it means that we can say that here the Q is flowing in this direction. What is the value of the Q? 0.267. Okay. So in this direction Q is how much? 0.5. In this direction Q is how much? 0.267. Okay. Is it clear?
Clear, sir.
So what will the total Q should be supplied by this one? So total Q,
0.767.
yeah, so
0.767.
Q compensator will be 0.5 plus 0.267. So final answer will be 0.767. Okay,
Got it. Thank you, sir.
is it clear? So like every time when power flow thing will be asked, we should calculate the apparent power equation at which node we are. See, I am doing calculation here. I am power flow nodal analysis I am doing here. So I have to calculate the equation here. If here I am doing the power flow calculation, like here some source will be connected or something will be connected. So with respect to that bus, we should do the VI conjugate. After that, we can equate the powers. We can do the power nodal analysis and we can get the final reactive power answer. Is it clear?
Yes,
I
sir.
think like with this information, you can solve any type of VI like power flow type question. Like it will be easy only, not a tough.
Yes, sir. Easy, sir.
Any place you can find this kind of question, you can try to solve it yourself. Just remember one thing: apply VI conjugate at that node where the information will be given. Okay. Okay. So thank you all. Next class, what should I cover? Can anyone tell me what you want to cover in the next class? Should I come with power electronics question only, rectifiers?
Sir,
Any?
sir, which topic is more important? We'll cover that topic, sir. For gate point of view, which
Okay.
is more important? Which
Okay, so
topic is more important?
DC converter already I have taught like maximum variety
Cover,
of
sir.
questions.
For
Okay,
DC
so
to DC converters, we got confidence, sir.
okay. So rectifier is easy only. Rectifier I will start with like previous year questions only. Rectifier also easy, like some variety of questions will be there. That will be very easy. Like 2 marks question will be asked. That will be easy only. So some rectifier based question I will start from single phase. Then I will go to the three phase also will be easy only. So I will do the questions like that, some single phase and three phase combinations. Okay, and some formula I will summarize, like how to like memorize that kind of like input power factor and those kind of formula. So that will give you confidence in solving the rectifier based questions also. That will be easy only. So rectifier portion I will cover. Maybe 2 marks or 4 marks question will come from that part in gate. Mostly they will ask input power factor. Okay.
Okay.
So I will come up with rectifier in the next class.
Okay, sir.
Okay. Thank you all.
Thank you, sir. Thank you once again. Happy Diwali.
Happy Diwali to all. Thank you.